Welcome and thank you to LaPierre for hosting this video. Today I'm going to talk about some considerations for tapping in order to achieve high maple sap yields. This certainly is not a comprehensive video in any way. There are many other things, but this just presents some of the research that we've worked on over the past several years and some things that may not be real apparent to people when they first start thinking about tapping, and I hope that you leave with an appreciation that it's not as simple as putting a bit in a drill and heading out and tapping trees. There's some thought that should be given to what you're actually doing, and those considerations, if you think about them ahead of time, will produce more sap and put more money in your pocket, and that really is the objective of this work. So with that, what we're looking at is trying to find ways to maximize sap yield, and we want to do this in a very sustainable way, and we want to do it economically in a way that doesn't cost you too much and actually results in a net profit for a producer. So we have to start with good tapping practices and realize how those choices that you make or the practices that you use are going to affect your yield. We have to realize that the objective when we're tapping is to maximize yield as much as possible, but minimize the impacts that we have on the tree. Because in doing this, we're going to make sure that the long-term sustainability of the tree health is good, and that in turn will come around and produce good sap yields for us in the long term. It's also important to understand how these different factors and decisions that we make are going to influence sap yield and wounding, and producers should then choose the practices that are going to produce the highest sustainable sap yields and generate the highest profits. So in making these decisions, we want to reduce the practices or errors that will lower sap yields and find things that are going to give us more sap or produce the highest amount of sap that's possible. So we want to get more sap, lose less money when we tap. So there are lots of different things that can affect it. Again, this is not a comprehensive list, but just some of the more important factors, and they include things like spout diameter, the tap hole depth, it's the depth at which we seat the tap hole, and the staining in the wood and how that affects yield. So first we're going to talk about spout diameter. In most cases, people are going to be using 5/16 or close to 5/16 1964-inch spouts. The 5/16 inch spouts were developed in the late early 2000s, and then actually the late 1990s first started coming into use in the early 2000s, and are used almost exclusively now for vacuum maple tubing operations. The 7/16 inch spouts were used formerly and are still used by some people. Primarily people are using buckets or gravity tubing, although many folks have already switched over to 5/16, even using that type of technology. Now the big thing that's asked is, well, if going to a smaller spout can produce the same amount of yield, going from 7/16 to 5/16 produces the same yield, why can't we go smaller with vacuum and will we get the same amount of sap? And the answer is no. While we see that we do have a modest sap yield lost from 7/16 to 5/16, when we go from 5/16 to 1/4 inch, we do find that there is about a 10 to 11% reduction in yield. And this work has also been confirmed by Center Acer in 2015. They found about the same thing, same type of range, about 11% reduction in sap yield when we go from 5/16 to 1/4 inch. Now, there may be other reasons for using a 1/4 inch spout. We'll certainly going to make a slightly smaller wound in the tree. It's going to produce a slightly smaller stain volume. So if you're tapping trees that are sort of on the edge in terms of growth rate, they're growing slowly, and you've already thinned, but for various reasons, the trees are growing slow, or you just want to be extra cautious in that area for some reason, then maybe a 1/4 inch spouts would be a good choice. But you should make that choice knowing that you are under vacuum going to see this 10 to 11% reduction in yield. So for that reason, most best management practices suggest that optimal yields are gained with a 5/16 or 19/64 inch spout. Below 1/4 inch diameter for spouts, so 3/16 or 5/32 inch spouts, the so-called micro spouts, we do find a continued drop off and actually an acceleration in drop off in yields, so that by the time you get to about a 5/32 inch spout, you're getting maybe 70% of the yield of a 5/16 inch spout. Most sites, trees on most sites that have reasonable growth rates can support the long-term use of 5/16 inch spouts, as long as you have drop lines of a sufficient length to allow you to spread out the wounding across the entire tapping band. So it's important to make sure you're using drop lines of at least 30 inches, but 36 inches is probably more appropriate for these days. And consider practices in areas where that have been tapped for a long period of time of perhaps tapping below the lateral line in order to make the tapping band even larger. Next, we're going to move on to the tap hole depth, the actual depth that we drill the tap hole. And when I talk about this, I mean the setting that we actually are using for the depth, not, and this includes the bark. So when I say 2 inches, I mean a bit that is drilling 2 inches from the outside of the tree in, encompassing the bark. So if we look at this graph and we use a 1.5 inch deep tap hole, again including the bark, as the 100%, just so we have a common scale here, we see that a 1.5 inch deep tap hole is probably not optimal for vacuum operations. Yet if we go just a little bit deeper, down to about 1 3/4 inch and beyond that, we find that sap yield levels off. Below 1.5 inches, we have a rapid drop off in yield where we're simply not able to access all the sap that's in a tree fast enough. And there are two factors here: how much is in the tree and how fast we can get it out during any flow period. But below 1.5 inches, we aren't able to get all that sap out for the average flow period, and even 1.5 we're not able to get it all out. But once we get to about 1.75 inches and above, then we're accessing largely the volume of sap that's within the tree within the average flow period. So what this chart shows, and this is research done over 3 different seasons and in many hundreds of trees, we see that tap hole depth above 1.75 really is not going to help you in terms of gaining additional syrup. It's simply going to make a larger wound in the tree. And again, we want to try to maximize our yield, minimize our wound. So 1.75 inches, perhaps if you want to be a little less conservative, then 2 inches deep would be sufficient, assuming you have good vacuum. The vacuum is going to be able to pull the sap for quite some distance within the tree, but again, the timing is important. We want to make sure that we're getting all that sap out of the tree within the flow period. So tapping deeper than about 1 3/4 to 2 inches deep, including the bark, doesn't seem to produce any appreciable increase in sap yield, but does impact sustainability. Now, if you have really old trees with very thick bark, perhaps you could go to the 2-inch, maybe 2¼ inch, but generally for most trees, 1.75 to 2 inches is sufficient to get good yields. As part of this tapping, there's been this question for a period of time as whether or not you slant the taphole. In historical practice with larger spouts, the 7/16 inch or above, was always to drill into the tree upward at a slight angle, and that was thought to prevent ice, sap from building up and freezing within the taphole and pushing the spout out of the taphole. Once there was this movement to 5/16 inch spouts, the recommendations of most manufacturers was to drill the taphole straight in, because this prevented the formation of oval tapholes and resulted in fewer micro leaks under vacuum, particularly under high vacuum. If we do have oval tapholes, it will produce vacuum leaks. So it is important to drill good tapholes that are round and not oval. But it turns out that geometrically, drilling at a slight angle upward does not actually create an oval taphole. You can't create an oval taphole with a round bit unless you move the bit. Now, the projection of that taphole, or the way it looks when you're looking at it from straight in versus looking at it at an angle, may appear to be oval, but it actually is round if you look at it at the angle that the drill went in. And that's the important thing. That is the angle that the spout is going to go in. That's the angle of the taphole. And as long as you did not move the drill or the bit while you were drilling, then the taphole should be round. So we did a study to look at this, and we found that, in fact, when you do drill either at a straight into the tree or at a slight angle, as was previously recommended, it makes absolutely no difference. The taphole is essentially the same, and you're not creating micro leaks, you're not creating an oval taphole with a slight angle. So in general, you can drill them however you want, as long as you drill the hole without moving the drill or the bit. So you want to make sure you have a good stable footing. Drill goes straight in, comes straight back out. Where we do tend to see oval tapholes is people doing it quickly, or if you're trying to drill way up over your head and you don't have good stable footing, and you can't see what you're doing as well if it's that high. But as long as you're drilling correctly, you're taking your time and doing it, you're going to be able to drill a straight taphole or nice round taphole, even if it's at a slight angle or slant. So there's no difference in size. Spout seeding depth turns out to be a fairly important factor when we look at tapping and yield. The real question is, how far do we pound in the spout? And I say pound, I really should say tapping. We're going to tap the spout in, not pound it in. It's not a nail, it is a spout. We only want to seed it far enough to engage it within the tree so that it holds within the tree without coming out during a freeze, but not so deep that it either splits the bark or creates micro leaks by creating these tiny cracks in the bark, or that it seals off more wood than it should, so we aren't getting good sap flow into the spout because it's just seeded too deeply. So tapping is best done by sound and feel, and the object is to seat the spout and not to drive it in as far as it will go. That's something that is very important to teach, especially new tappers, that we aren't driving these things in like nails, we're just tapping them in far enough to seat the spout. The best indicator, or one of the best indicators, is the change in pitch. As you as you pound the spout, or as you tap the spout in, you can hear the change in pitch when it gets that far. Now, some people will hit it one more time lightly afterwards just to make sure, but generally once you detect that change in pitch, or the slight bounce of the hammer is sometimes always a good indicator. And that's best felt by using these lighter tapping hammers as opposed to the large metal framing hammers that people sometimes like to use. Those are really good for driving nails, not so good for seating spouts. So these smaller wooden or plastic hammers are designed to be able to allow you to tap spouts properly. So we really advocate for people to use the proper tool for the job. In this case, a tapping hammer is the right tool for the job. Similar to the way a good maple drill bit is the proper tool for tapping. We don't want to use just standard wood bits. They aren't designed to remove wood chips properly. They're designed to make a hole in lots of different materials, not just wood. So use a proper drill bit that's made for maple tapping, and use a proper hammer that's made for maple tapping. So if we actually look at how overdriving spouts affects yield, what we find is that in a correct situation, this lowest spout on the figure on the left, if we drive it in properly, we achieved about a 27.5 gallons per tap in this particular study, and the sap sugar content averaged 2.33 over the season. Now, if we hit them a little bit harder and drove them in another quarter inch or a third of an inch or so, what we found is that the yield dropped off by about 9%. And similarly, the sugar content of that sap dropped off. So we're getting sort of this dual negative effect where we're sealing off more of the newest wood from the tree. That newest wood has the highest sugar content. So by going just a little deeper, we're getting a little less sap, and we're getting less sweet sap. So overall, it's a significant reduction in syrup yield when we convert that sap into syrup. So just by tapping properly, we could see about a 10% overall change in syrup yield. Now, if we take somebody who's really inexperienced and they go out there and they have a large hammer and they treat a spout like a nail and they really pound it in right up to the hilt, what you find is that you lose a lot of sap. In this case, over 40% sap loss, and our yields, rather than being about 27.5 gallons per tap, we're way down at about the 16 to 16.5 gallons per tap. So tapping spouts in at the proper depth is very, very important. Make sure you do it right, and you'll get a lot more sap. And then last, we're going to talk about staining a little bit. And for this, what's important to recognize is that the stain in a tree is an area of wood that does not transmit sap and doesn't give up sugar. So when you're tapping, you always want to tap into this good white wood, and you don't want to tap into an area that's been previously tapped or around an area, especially above or below an old taphole, because you're going to see brown wood that is not conducive to moving sap through it. So you're going to get very, very poor sap flows from those tapholes. And when we actually measure this is work done by Mark Iselhard of UVM Maple Extension, and we have stained wood across the bottom from 0 to 100% and syrup yield on the y-axis. What we find is that the proportion of sap is directly correlated to the amount of stained wood that you hit in a taphole. So if you hit very, very little stained wood, you end up with very good yields. If you hit a lot of stained wood, you end up with much, much lower yields. So that relationship is essentially linear. We can use that to sort of say, what percentage of sap am I going to lose? So if we monitor the amount of stained wood that we hit, or the percentage of tap holes that we actually hit stain in, and we divide that by 2, so we're estimating that we're roughly going to lose about 50% of the sap, then that will tell us over the entire sugar bush what percentage of sap we actually could lose. So for an example, if we hit stain 10% of the time, and we divide that by 2, because we're losing about half the sap from each of those tap holes, we're going to lose about 5% of our sap from the entire sugar bush. Now, that doesn't sound like a lot, but let's continue doing a little bit of math and see where it leads us. Well, if we are achieving yields of about 10 gallons of sap per tap, which isn't particularly high, but just say we get a modest rate of 10 gallons of sap per tap. That means we've lost half a gallon of sap per tap over the entire sugar bush. And if sap is worth about 50 cents per gallon, that means we've lost a quarter per tap over the entire sugar bush. Now, how many producers do you know, if you saw a quarter at the base of every single tree in your sugar bush, wouldn't bend over and pick it up? Well, I'm not asking you to go around looking for quarters in the sugar bush. What I'm asking you for is look for the stain that you're hitting. And if you're hitting stain, do something about it. You don't want to leave that quarter for every tap out in your sugar bush. So you might think, well, I'm not hitting stain 10% of the time. Well, you don't really know unless you actually look at it. And you don't need to look at every single tap, but maybe every 5 or every 10, just take a peek. You're going to see a little bit of bark, and that's brown, but for the actual wood, it should look nice and white and creamy. So let's say maybe you hit it only 5% of the time, but you're getting close to half a gallon per tap. You're going to end up with about the same thing, 25 cents per tap lost. Now, if you're actually selling syrup retail, your sap is worth more than 50 cents a gallon. It's closer to about $1 a gallon. So if you're doing that, you're actually going to be maybe losing over 50 cents per tap. And if you're converting that into cream or candy or some other way, you could be losing up to $1 per tap simply because you're tapping into stained wood. And there are things you can do to avoid doing that. So again, what we're trying to do, get the maximum amount of sap we can out of the tree, or not lose sap that we could collect. We want to do it sustainably and economically. We have to understand how those decisions that we're making influence yield. Tapping is really critical in ensuring that we're doing a good job in making money in maple. So we don't want to take the youngest, most inexperienced people and send them out in the woods with some spouts and hammers and let them go, and drills, and let them go at it. You want to make sure you're doing things right. It's the first place to mess up. It's the first place to start to lose money in your operation, and you probably can't afford to mess it up there, because you can't change it. You can't go back. So those very small changes and decisions that you make in the practices that you use are going to have a large impact on your yield and on the economic gain of your operation. Don't let these small errors cut back on your profits in a big way. I'd much rather see you do it the right way and put them in your pocket. And then lastly, just want to point out that there are several resources online that have been produced by UVM over the past several years. Some of them are available directly on the Proctor Center webpage, but if you go to the North American Maple Syrup Council, mapleresearch.org, that the Proctor Center put together, it shows a lot of the research that's been done over the past 20 years that will help you increase your yields. Many of those are now being put into video format on YouTube, and you can find out about grading techniques and high yield production on the UVM Proctor Maple YouTube channel. There's a lot of valuable resources on the UVM Extension Maple program website, and more business program information being done on VermontMapleBiz.org and MapleManager.org websites. So with that, thank you, and if you have questions, feel free to email me at timothy.perkins@uvm.edu, and I'd be happy to try to answer them. Thank you very much.